Imagine waking up one day, looking up at the sky and realizing that one of our neighboring planets just vanished. Poof! Gone, not just hidden behind the moon or anything, but completely erased from existence. What would happen? How would that affect Earth, the solar system, and even us? It's a question that tickles the imagination of anyone who's ever gazed up at the night sky and pondered the vastness of space. Today, we're diving deep into this cosmic thought experiment. We're going to explore the intricate gravitational dance of our solar system and unravel what would transpire if one of the dancers were to suddenly leave the floor. Let's start with Mercury, the smallest planet in our solar system and the closest to the Sun. You might think that its small size would make its disappearance insignificant, and you wouldn't be wrong. Mercury's gravitational pull on other planets is minimal due to its, lack of mass. So if Mercury were to vanish, Earth and the other planets would likely not feel a thing. Their orbits would remain virtually unchanged, and life would go on as usual, at least from a gravitational standpoint. Skywatchers would notice a difference, though. Without Mercury, those fleeting appearances near the Sun would cease, leaving a small but noticeable gap in the celestial tapestry. Next up is Venus, Earth's closest planetary neighbor. Often referred to as our sister planet, Venus is truly fascinating. While still relatively small compared to the gas giants, Venus is significantly larger than Mercury and exerts a much stronger gravitational pull. Now imagine if Venus were to disappear. It would be like removing a slightly heavier dancer from our cosmic ballet. The overall choreography wouldn't change drastically, but the remaining dancers would definitely feel a slight shift in their movements. For Earth, this means our orbit around the Sun would be subtly altered over time. These changes would be subtle, taking thousands, if not millions of years to become truly noticeable. However, the absence of Venus's gravitational tug could eventually lead to a tiny change in Earth's tilt and the shape of our orbit, which might slightly affect our seasons in the very long term. But perhaps the most noticeable change would be in the night sky. Venus, often called the evening star or morning star due to its brilliant appearance near sunrise and sunset, is the third brightest object in our sky after the sun and moon. Imagine the night sky without it. Now, this is where things get really interesting, if not a little existentially terrifying. What would happen if Earth, our home planet, suddenly blinked out of existence? From our perspective, it would be the end of the line, but let's take a detached cosmic perspective for a moment. From the vantage point of the remaining planets, Earth's disappearance would be like losing a moderately sized dancer in the grand ballet of the solar system. Mars might feel a bit less of a gravitational tug. Venus might experience a slight shift in its orbit over eons, but nothing catastrophic. The Sun, the true heavyweight of our solar system, would barely notice the difference. However, there would be one lonely celestial object left adrift by Earth's disappearance, our Moon. Without Earth's gravity to hold it in orbit, the Moon would become a cosmic wanderer. It might drift through space, a silent testament to a planet that once was. Or, if it passed close enough to another planet with a strong gravitational pull, it could potentially become a satellite of a new world. Let's shift our focus to the red planet, Mars. Mars has captured our imaginations for centuries. We've sent rovers, landers, and helicopters to explore its dusty plains. But what if Mars simply vanished? Its disappearance wouldn't disrupt the solar system. Earth would continue its orbit around the Sun. However, the loss of Mars would impact our understanding of the solar system. Mars is a treasure trove of scientific information. Its disappearance would be a huge setback for planetary science, and let's not forget the human element. Mars has been a prime target for human exploration for decades. Now we're entering the realm of the true heavyweights, the gas giants. Jupiter, the largest planet in our solar system, is like the cosmic elephant in the room. Its gravitational pull affects the orbits of every other planet, including Earth. Jupiter acts like a cosmic bodyguard, deflecting comets and asteroids. But what if Jupiter suddenly disappeared? The entire structure of the solar system would be at risk of collapse. The asteroid belt would be thrown into disarray. Some asteroids could be on a collision course with Earth. The orbits of other planets would start to shift unpredictably. Saturn, the ringed jewel of our solar system, is another gravitational heavyweight. While not as massive as Jupiter, Saturn still exerts a powerful influence on its celestial neighbors. Its iconic rings, made up of countless icy particles, are a testament to the planet's gravitational prowess, holding this cosmic debris in a delicate dance for billions of years. So what would happen if Saturn suddenly vanished from the cosmic stage? Like with Jupiter's disappearance, the consequences would be significant, albeit less dramatic. The orbits of the outer planets, Uranus and Neptune, would be most affected, as they would feel the gravitational tug of their massive neighbor disappear. Over millions of years, their orbits could become more elliptical or even chaotic, potentially leading to close encounters or even collisions with other celestial objects. Saturn's absence would also disrupt the delicate gravitational balance of the asteroid belt and the Kuiper belt. a region beyond Neptune populated by icy bodies and dwarf planets, including Pluto. This could lead to a surge in cometary activity as these icy bodies are nudged out of their stable orbits and sent hurtling towards the inner solar system. Uranus, the ice giant with the quirky tilt, is often overlooked in our solar system. It's not as massive or visually striking as Jupiter or Saturn, and its distance from the Sun makes it a faint object in our night sky. But don't let its understated presence fool you. Uranus plays a crucial role in maintaining the delicate gravitational balance of the outer solar system. So what would happen if Uranus suddenly vanished? Would the solar system descend into chaos? The answer, thankfully, is probably not. Uranus's gravitational influence, while significant in the outer reaches of the solar system, has a minimal effect on the inner planets, including Earth. So, from our perspective, life would likely go on as usual. However, the disappearance of Uranus would have significant implications for the objects in its immediate neighborhood. Neptune, its closest neighbor, would feel the loss of Uranus's gravitational tug most acutely. Over millions of years, Neptune's orbit could become slightly more elliptical, potentially affecting its interactions with the Kuiper belt and the objects that reside there. Speaking of the Kuiper belt, Uranus's disappearance could have a ripple effect on this vast region of icy bodies beyond Neptune. Neptune, the outermost planet in our solar system, is a world of mystery and intrigue. Its deep blue atmosphere, whipped by supersonic winds, hints at a turbulent and dynamic world hidden beneath its frigid clouds. Neptune, along with its gravitational companion Triton, marks the boundary of our solar system, a celestial sentinel guarding the gateway to interstellar space. But what if Neptune were to suddenly vanish? What would happen to the Kuiper belt, that vast collection of icy bodies that orbit beyond Neptune? Without Neptune's gravitational influence, the Kuiper belt would become a much more chaotic place. The orbits of these icy bodies, no longer stabilized by Neptune's presence, would become more eccentric and unpredictable. Some of these objects could be flung inwards towards the Sun, potentially crossing paths with the inner planets, including Earth. Others might be ejected from the solar system entirely, cast adrift into the vast emptiness of interstellar space. The Kuiper belt, once a relatively orderly region, would become a cosmic shooting gallery, with objects hurtling in all directions. Pluto, the demoted ninth planet, might be small, but it holds a special place in our hearts. Once considered the ninth planet, Pluto was reclassified as a dwarf planet in 2006, sparking a debate that continues to this day. But regardless of its official designation, Pluto remains a fascinating and enigmatic world, a resident of the distant and icy Kuiper belt. But what if Pluto were to suddenly vanish? Would the solar system even notice? The answer, in short, is not really. Pluto is so small, its gravitational influence on the rest of the solar system is negligible. Its disappearance would be like removing a grain of sand from a beach. The overall impact would be practically non-existent. Even the Kuiper belt, Pluto's home turf, would barely register its absence. While Pluto does interact gravitationally with other Kuiper belt objects, these interactions are relatively weak and infrequent. Pluto's disappearance might cause a few minor orbital perturbations among its closest neighbors, but nothing that would significantly disrupt the overall dynamics of the Kuiper belt. So there you have it, a cosmic thought experiment exploring the consequences of a planet disappearing from our solar system. As we've seen, each planet, from tiny Mercury to massive Jupiter, plays its own part in keeping the solar system balanced. While some planets, like Mercury or Uranus, could disappear with minimal effect, the loss of Jupiter or Saturn would be far more impactful, potentially reshaping Earth's destiny and sending shockwaves throughout the solar system. This planet-by-planet breakdown shows how each one contributes to the solar system structure in unique ways, and how their disappearance could impact us here on Earth. It's a reminder of the interconnectedness of our cosmic neighborhood and the delicate gravitational dance that keeps everything in its place.